All right, so far we have talked about two methods for solving. One of them is solving by graphing, and the other is solving by substitution. Now, the key with using substitution is that we need to get a variable by itself. We need to get a variable by itself. However, sometimes it's just not the easiest way to get a variable by itself. So, for example, let's say I have this system 2x plus 3y equals 34, and 4x minus 3y equals negative 4. Now, so far, the methods that we've learned are graphing, which if I were to graph this, I would have to solve both of these equations for y, which I can do, but I just want you to think about what would happen if we solve for y. Like take this first one, for example. I would subtract 2x from both sides, and then I would have to divide everything by 3. Now, what happens if I do 34 divided by 3? That's not a whole number, okay? So I could graph it, but I'm dealing with some fractions that are going to make it kind of tricky to graph. Same thing goes with substitution. If I want to use substitution, I need at least a variable that will be by itself. And no matter what, if I choose an x or a y from either equation, if I try to get a variable by itself, it's going to make it so that we have fractions, okay? Which obviously fractions are not the end of the world, but it's good to have different methods for solving because you'll see right now that this elimination method is way easier than using either of the other two methods in this case. So here's the key idea with elimination. With elimination, we add the equations together vertically. So it's important that you note that the x's are lined up, the y's are lined up, and the constants and the equal signs are lined up. So watch what happens when I add these together vertically. 2x plus 4x gives me 6x. 3y plus negative 3y gives us 0y. So it is eliminated, hence being called elimination. Our goal is to eliminate one of the variables. 34 plus negative 4 is 30. So we add everything together, add the x's, add the y's, add the constants. And now I'm left with a one-step equation to solve for x. Divide by 6. And now I get x equals 5, which I'm not done because I have to figure out what y is. So I go back to one of these original equations. It doesn't matter which one I choose. I'm going to choose the first one. So instead of 2 times x, I'm now going to have 2 times 5 plus 3y equals 34. 10 plus 3y equals 34. I'm going to subtract 10 from both sides. Get 3y equals 24. Now I'm going to divide both sides by 3. And we get y equals 8. So my answer is 5, 8. So again, I could solve this system using any method. I could graph them, I could use substitution, or I can use elimination. And it's going to be up to you what method you want to use. But some systems lend themselves to having elimination be the easiest method. Some of them, substitution is the easiest method. I personally would never choose graphing as my preferred method just because graphing takes a while. So I usually choose either elimination or substitution. But let's try another one. So part B. So we're adding these equations together and we're finding that it works out pretty nicely. So let's say I have 2x plus 6y equals negative 8. And then I have 5x minus 3y equals 88. All right, so if we were to approach this just like we did in the first example, I would add these together. I would do 2x plus 5x, that would give me 7x. 6 and negative 3 would give me 3, and negative 8 and 88 would give me 80. The problem is nothing eliminates. Like up here, I had 3y and negative 3y, and we had the y's eliminate. That doesn't happen here. So we have to add a step in. First, you have to multiply one equation by something. And that something is going to change depending on what the numbers look like. So I want you to look at these two equations, and I want you to imagine that we're going to multiply one of the equations by a number, so that way one of the variables could eliminate. So what I do is I look and I see, well, I have 6y, and if I were to eliminate 6y, I would need a negative 6y. Well, I have a negative 3y, so I can just multiply this whole second equation by 2. And that's what it'll give me. I'm going to distribute this. And this is really important. It's really important that you multiply everything by 2. So I'm going to have 10x. 2 times negative 3 gives me my minus 6y. And I have to do 2 times 88. That's really important. Students always forget that. This number over here has to get multiplied as well. 2 times 88 gives me 176. And now I'm going to add these two equations together. So the original first one and the new version of my second equation. And when I do that, 2x and 10x gives me 12x. 6y and negative 6y eliminates, which is what we wanted. And negative 8 plus 176 gives me 168. And now we're just in the same boat as we were in the first example. I'm going to finish solving for x. So we get x equals 14. And then I'm going to go back and plug this in to one of the original equations. It doesn't matter which one you choose. I'm going to do the first one. So instead of 2 times x, I'm going to have 2 times 14, which gives me 28. And now I need to subtract 28 from both sides. We get 6y equals negative 36. Y equals negative 6. So my answer would be 14, negative 6. All right, let's try another one. We're going to step it up another level here. Let's say I have 2x plus 4y equals negative 10. And I have 3x plus 3y equals negative 3. Okay, so why is this stepping it up a level? Well, in order to make something eliminate, I'm actually going to have to multiply both equations by something. Then add. Right? Because there's nothing that I can multiply this top equation so that I get negative 3x, and same thing with the y's. However, I can change both of them and make them the same number. So I can make 2x into 6x, and I can make 3x into negative 6x by multiplication. So I'm going to multiply this top equation by 3 to give me 6x, and I'm going to multiply the bottom equation by negative 2, so I have a negative 6x. And remember, we're going to multiply everything in the equation by that number. So we're going to distribute. So I get 6x plus 12y equals negative 30, because I have to do 3 times negative 10. And I'm going to do the same thing down here. Negative 2 times 3x is negative 6x. Negative 2 times 3y is minus 6y. Negative 2 times negative 3 is a positive 6. And now I can add these together. And again, we're going to add every single thing. So 6x and negative 6x, that eliminates. 12y and negative 6y is 6y. Negative 30 plus 6 is negative 24. I'm going to divide by 6. You get y equals negative 4. Now I'm going to go back and plug it in. Again, it doesn't matter which equation you choose. That is up to you. I'm going to choose the first one. And instead of 4 times y, I'm going to have 4 times negative 4. So I have 2x plus 4 times negative 4 equals negative 10. That gives me 2x minus 16. And now I'm going to add 16 to both sides, which gives me 2x equals 6. Divide by 2. We get x equals 3. So my answer here would be 3, negative 4. All right, so let's try something else. We are going to determine the number of solutions. So remember, a system can have one solution, which all of the examples that we've done so far had one solution, an x and a y that worked for both equations. Some systems have no solution, 0 solutions, and some have infinitely many solutions. And we know what that looks like if we graph the lines, but what happens if we're solving by elimination or substitution? So for example, let's say I have this 2x plus y equals 8 and 6x plus 3y equals negative 15. All right, so we have a choice. We can solve this using substitution or elimination. It will work either way. And this is actually a system where you could easily choose whichever method you wanted. I'm going to use elimination here. So I see that I have a 3y, and if I could just make that a negative 3y, those would eliminate. So I'm going to multiply this top equation by negative 3. So negative 3 times 2x gives me negative 6x. Negative 3 times y gives me negative 3y. And then negative 3 times 8 gives me negative 24. Okay, so now I'm going to add these two equations together. All right, 6x and negative 6x, that eliminates. 3y and negative 3y also eliminates. So I'm left with nothing. I'm left with 0 on the left-hand side of the equal sign. Negative 15 plus negative 24 is negative 39. Okay, both x and y canceled out, and we are left with a false statement. 0 does not equal negative 39. So that means that this system has no solution. This system has no solution. All right, let's look at a scenario where you might have infinitely many solutions, so you know what that looks like. And we'll do a little review of substitution. So let's say I have 56x plus 8y equals negative 32. And let's say I have y equals negative 7x minus 4. Okay, so this system is set up for substitution because we have a variable that is indeed all by itself. And what is y equal to? It is equal to negative 7x minus 4. So I'm going to take that and I'm going to put it in the place of y in the first equation. So that's going to give me now 56x plus 8. And instead of y here, I'm going to put negative 7x minus 4 equals negative 32. All right, now I need to distribute the 8. So I have 56x. 8 times negative 7x gives me a minus 56x. 8 times negative 4 gives me a minus 32. Well, my 56x and my minus 56x cancel out. And I'm left with negative 32 equals negative 32. So again, my variables totally canceled out, and I'm left with a true statement. Negative 32 does equal negative 32, so that means we have infinitely many solutions. All right, that is it for elimination method.